So today we're going to look at section 10.1 to start out with, which is coordinates of points in a plane. Okay, so before, this is just to look at now, when we graphed a point on a number line, okay, we only needed one line. Okay, when you graph a point, like the number 4, the number 5, it's just a single line. Okay, what we're going to do is look at we're going to look at graphing a point that has two numbers in it, okay? And that's called a coordinate, right? So we're not going to just need one of these. We're going to need how many? We need two, okay? And they're called axes, okay? Each one is an axis. Okay, so to locate a point on a plane, we need two numbers. Okay, and then at the first blank where it says the two numbers are called, anybody know what you call those two numbers? They're inside, yeah, they're your x and y, and it makes up a coordinate. Yep, good. Okay, so there's two names. You can call it a coordinate or an ordered pair. Okay, so that's what goes on those two blanks. Called a coordinate or an ordered pair. Okay, the reason we use the name ordered pair is because they have to be in a certain order. X comes first, and then Y comes after it. Okay, that's an ordered pair. If we were going to talk about 3D, we'd have what's called an ordered triple. We'd have an X, a Y, and a Z axis. For today, though, and most of what we're going to do, we're going to just be 2D. Yeah?
Check AC.
What's that, Savon?
I have no idea what X, Y, Z was.
So I said that if we're going to do like 3D,
Oh.
you'd need a Z, X, Y, Z. So you have an axis that goes left and right, you have one that goes up and down, and then you have one that goes forward and back. That's
So there's
3D.
literally a one that can go through the other ones?
Yep, for 3D. Okay, we're going to stick in 2D though.
Would that be a triangle? I know I'm asking a lot of questions, but this is confusing.
What's that?
Would that like be a triangle?
No, 3 axes, you'd have one that goes left and right.
So it'd be like a corner of a square.
Yeah, one that goes up and down, and then you'd have one that goes in and out. It'd be 3-dimensional. But again, we're not doing 3D. We're just going to do 2D. So we'll have an axis that's going to go up and down, and we're going to have one that goes left and right. And that's it.
Triangle.
Okay. So when we draw these two axes, okay, we're going to have one that goes up and down, one that goes left and right. That's called a coordinate plane. Okay. And you have a picture of a coordinate plane right here. Okay, everyone get that on there? Okay, on the coordinate plane, there's two number lines. Okay. Those are called your axes. Okay, so those two, you have an x-axis, you have a y-axis, okay, and together those are called your axes, x and y. Okay, and they intersect at a point called the origin. Okay, so that dot right in the middle where the two axes cross, that's called the origin. Okay. What's the coordinates of the origin? 0, comma, yeah. 0. Yep, 0, comma, 0. So the x-axis, okay, that's the one that's your horizontal. Okay. Yep, left to right. And your y-axis, that's the one that's vertical. Okay, that goes up and down. So on your sheet, label your x-axis. I think Mr. Wright put an arrow for you, pointing right to the axis. And then he did the same on the one on the top. So it's your x and your y-axis. If you're not sure where to put it on the sheet, you can just write something separate below it if you don't want to label it this way. Okay, this is just if you want to use this, you can. It's up to you. Okay, so there's your x and y axis.
What's the minus and plus signs?
Okay, so we're gonna talk about that. So on each axis, okay, you've got two different directions you can move in. For the horizontal, you can move left or you can move right. If you go to the left, that's the negative direction. If you go to the right, that's the positive direction. Okay, that's already labeled for you on your sheet. Okay, on your y-axis, you also have two directions you can move in. Up is your positive, down is your negative. And that's also already labeled for you. Okay, what else do we have on here? Okay, we've labeled the origin. Coordinates of the origins, someone told us, is 0, 0. And then these positives and negatives, there's a spot where you can fill that out on your chart. Okay, so if you're in this upper right area, okay, in the upper right area, all your coordinates have a first number that's positive and a second number that's positive. That's how you get in the upper right, two positive numbers. Okay, if you're in the upper left, your first number is going to be a negative, and your second number is a positive. Okay, and then the same thing in other quadrants. Down in the lower left, that's when both your numbers are negative. And in the lower right, the first one's positive and the second one's negative. Yeah?
What's with the quadrants?
We're going to talk about quadrants in a second. We'll talk about that. Okay. Any questions on that?
No.
Okay, so notice when you draw these axes, it takes this grid and divides it into how many sections? 4. Okay. Those 4 sections are called quadrants. Okay, and the quadrants are numbered, starting in the upper right. Okay, so on your line where it says quadrant, upper right is quadrant 1. Upper left is quadrant 2. It's right on your chart, right there. Okay. Lower left is quadrant 3, and lower right is quadrant 4. Okay. Sometimes you see these with Roman numerals, but I usually like to use the numbers because most people are more familiar with that. And every single point that you graph is either in one of two places. It's either in a quadrant, or it could be on the axis. If a point, let's say you had a point right here. That point is between quadrants. Okay, it's not in either quadrant. We'd say it's on the y-axis. Okay? If you had a point like that, that's not in either quadrant. It's on the x-axis. So you're either in a quadrant or on an axis.
What if it goes off the graph?
Well, remember, this extends forever. So a plane can be as large as you want it to be. Generally, when I give you like a sheet for homework, it's going to look like this, because I'm not going to ask you to graph anything much bigger than that. But if you needed a whole sheet of bigger grid, you could do bigger. Yeah.
Is there going to be any homework in the book?
Yeah, we'll do that. The homework will probably be from the book, but you're going to need some graph paper to do it. Yeah.
Okay.
Yep.
But you're going to give us graph paper?
Yep, I'll give you graph paper. Okay, so every point on the plane has a unique coordinate. Yeah.
You can say long or give me this one.
Okay, that's good. Yeah, that's it. All right, so the idea is if you want to get to a specific coordinate, let's say you wanted to go right 1 and down 1. Okay, there's only one way to get to that point. Okay, there's a certain coordinate you could write down that would represent that spot. And there's only one coordinate. Okay? Each point that you put on a graph has a unique way to get to it. Okay, so let's look at the 2 steps for how you plot a point. Okay, if you see the words graph or you see the word plot, they mean the same thing. So we're going to start out by, we're not even going to graph lines yet. Just going to graph points. Okay. Step 1. Start at the origin. And then you're going to look at the first number. Okay. You're you're going to look at that value, the x value. If that first number is negative, you're going to move left. Okay? Because if you look at your chart, you look at your x-axis, negative goes in the left direction. Okay? If that first number is positive, you're going to move to the right.
Period.
Okay? Any questions about which way the
We
x-axis
need a period
tells you to move?
right between the negative and the one.
Yeah.
Yeah.
Okay, so move left if the first number is negative.
Because it looks like
Move.
negative,
Yep.
move right.
Move right if the first number is positive.
It just looked like negative, move right.
Any question on that?
We have to write that.
Well, I would make sure, I'm going to test you on it, so as long as you know how to do it. And Mr. Roy left a spot for you, so that's step one. Okay, now step one only takes care of your x value. We still have to worry about moving up and down. That's the y value.
Wait, I thought you started from 0.
Yep, you do. You start from the origin, always.
Yeah, but
start
why
from
does
one?
it say start from 1?
So now, once you do step two, you're going to take where you started, you're going to look at where you moved in step one, and from that point, you're going to move up and down. Okay? After step one, you're not at the origin anymore. You've moved left or you've moved right. Now from that spot, you move up or you move down. How do you know if you're going to move up or down? Well, yeah, you just look at the number if it's negative or positive. So move down if the second number is negative. Move up if it's positive. Okay, so we'll practice graphing some points. Okay, your coordinate is always written like this. We talked about it a little bit earlier. It's x, y. The x tells you which way to move horizontally, and the y tells you which way to move vertically. Okay. Any question on that? All right, so let's practice graphing some of these points. Okay, later we'll also try identifying which quadrants they're in. Okay, so on example one, you got a grid already drawn. I'm just going to use that grid to try to graph some of these points. Yeah.
Are these examples going to be used on the test?
Yep, I'll pick one of them.
Oh.
One from today, I'll pick one from tomorrow, and one from when, and so on. Yep.
Okay.
All right, so let's start with the point 5, negative 3. From the origin, who can tell me what you would do first? Isaiah?
Yeah, we're on the 5.
Yep, 5, negative 3.
So you go over 5 to the right.
Yep, so notice how he said right, that's important, 5 right. And then what?
And then you go down 3.
Yep.
Negative.
And then from there, you go down 3. Okay, so that should be your first point. 5, negative 3. Okay, the next one. Negative 2, negative 8. Yep, go ahead, Laura.
You start with the origin and go left 2.
Good, left 2,
And then down 8.
and then down 8. Okay, so that's where that point would go. Okay, let's look at the third one. Okay, it's negative, positive. Left 5, and then up 1. Okay, negative 5, comma 1. Okay, how about 5, 2? Somebody different, tell me, how do we graph the point 5, 2? About Katie, how do you graph the point 5, 2?
You go over this way 5 and up 2.
go to the left or to the right? Right 5. And then which way? How many? Good. Up 2. Every one of those points we just drew, they are all in a quadrant. Okay? The last 2 points are going to be on an axis. How would you graph 0, 3? What would you do for that, Spencer?
You would just move up 3 on
Yep.
the y-axis.
Perfect. Just move up 3
It's y-axis.
from that origin, y-axis. Good. The point 0, 3, if I asked you, is it in a quadrant? What would you say?
You would say it's on the y-axis.
Right, it's on the y-axis. That is not in a quadrant. And the last one, negative 4, 0. How do we graph that?
Go down west.
Go to the,
West.
which way is that? So left or right?
Bottom map.
Yeah, left 4, and then what? Yep, that's it. Okay, so we're just going to go left 4, and we don't move up or down. Question on that?
I don't know which makes me go.
So if you look at steps 1 and 2, you look at your first number. If it's positive, you're going to move right, and then if it's negative, you move left.
Are you gonna go down or up?
So you look at the second number. If it's negative, you go down. If it's positive, you go up. Right? All right, let's try the reverse of that. This time I've given you some points that are already graphed, and I want to find the coordinates. Okay, the grid might be a little hard to see from your seat, but it's the same grid that's on your paper. Okay, Ben, what are the coordinates of A? Let me make it a little bigger.
3/4.
Okay, go ahead, one more time.
3 or 4.
3, 4. Looks like we're going right 4, so that's, first number is going to be 4, comma 3. Okay? So 4, comma 3. How about point B? Anybody think they can see what point B is? Yeah, Mark.
-7.
Yep, negative 7.
-1.
And then we went up.
+1.
Yep, good. We went up, so that's positive. Okay, C. How do we get to point C? Yep.
-1, -2.
Yep, left 1, down 2. -1, -2. Okay, D. Let's see, that one we're going right 3, and it looks like down. How many? Yep. Yep. So negative means you go down. All those points, A, B, C, and D, A, B, C, D, they're all in a quadrant. They're all in different quadrants. How about E? Is E in a quadrant?
No.
Nope, it's on an axis. So if it's on an axis, one of the two numbers has to be what? 0. Just got to figure out which one. Tyler?
0, 8.
0, yep, 8. This grid is 10 by 10, so if you're up here, you're 2 units from the top, which is at 8. Good. Okay, any questions on that? Okay, let's look at the next type, which is identifying the quadrant. So your choices are 1, 2, 3, or 4. Or you could say it's on the x-axis or y-axis if it's not in a quadrant. Okay, 3, 4. You can tell me what quadrant that's in. Yep, quadrant 1, good. How about -4, 5?
2.
It's left and up. 2. Caleb, can you give me the C?
2.
Let's see, so we're going right and down.
4.
So if you go right and down, you're somewhere over there, which is which one someone said?
4.
That's 4. How about -6, -1? Yep. -6 means you go left. -1 means you go down. Now you're over here. That's quadrant 3. What about 0, 2?
Y-axis.
Yep. That's on the y-axis. Okay, anytime you see a 0, you're not in a quadrant. Okay, you're on the y-axis. Okay, any question on that?
No.
Okay, so we're almost done 10.1, and then we'll do the section that might be new for some people, 10.2. Okay. What's a point that's directly above 4, 5? What would be the next one right above it?
6.
Yeah. It would be 4, 6. So which value changed when you went above? Did it the x or the y?
Y.
Yeah, it affect the y. Okay. Let's try this. What's a point to the right? Just 1 unit to the right of 4, 5.
5.
5.
Yep. Okay. 5, 5 is a point that's to the right. Okay. So when you move left to right, which value does that affect? That affects your x. Okay, so that's what we just said. Notice if you're given a point and you want a point that's above or below, you change the y. If you want a point that's to the left or the right, you only change the x. Okay? Does everyone understand that changing the y value affects the vertical? Changing the x value affects left and right, that's your horizontal? All right, so we're going to use that idea to solve a problem. Okay, so you don't have to write that part. We're just going to use it to figure out. Okay, they're giving us 3 corners of a rectangle. Yep, this is example 4. Yep, it's right on the bottom.
Right next to example 3.
Yep. Okay, they give us 3 vertices of a rectangle, and they want us to find the 4th one. Okay, so let's start by graphing these points, okay, and figure out what the 4th coordinate would be. So we've got the point 1, 1. How do we graph that? Isaiah?
Over 1 on 1.
Okay, yeah, right 1, up 1. How about the point 6, 1?
Over 6 or 4.
Over to the right 6, up 1. How about 6, 4?
Over 6 up 4.
Over which way?
Right.
Right 6, up 4. So 1, 2, 3, 4. And now, since we're doing it by graphing, okay, it makes it pretty easy to figure out. But the point, when you tell me what the coordinates are of that point, it has to have something in common with that point, and it also has to have something in common with that point. Okay, so let's just write down what this was. 6, 4, and 1, 1. What's going to be the coordinate of that point right there? And that's the answer. Yep. 1, 4.
Why is that the answer?
So you go right 1, up 4. Now look at this point. This x value and that x value are exactly the same. Because when you have a rectangle, the 2 points on the left-hand side have to line up vertically. Okay? And we just said earlier that if you have a point and you want it to line up vertically, all you do is change the y value. Okay? Now let's look at this coordinate. We went up 4. We went up 4 for both of those points. Because on the top side of a rectangle, the 2 points have to line up horizontally. What does that mean if they line up horizontally? They're at the same height. Their y values are exactly the same. It's their x's that are different. Okay, so this point that we just found it took its x value from the point directly below it, took its y value from the point that was right to the right side of it.
Can we connect them?
Okay? Yep, and if you connect them, you'd have a rectangle. Okay, so that's a quick review of 10.1. Any questions on 10.1? All right. Let's take a look at 10.2.
It just completely jumps to different subjects.
And now we're going to do section 10.2, because 10.1 was quicker. Okay. 10.2 is on what we call relations and functions. So we're going to look at 10.2. Okay, first thing I want to do is look at just this example. Okay, I just want you to look at it, listen to me. You don't have to write this down. Okay, so here's an example. It says Ann worked as a lifeguard, and she basically makes $7 an hour. So in 1 hour, she makes $7. Okay. One way we could represent that would be like that, okay, as a coordinate. In 1 hour, she makes $7. In 2 hours, she makes 14. Okay, so coordinates are a handy way to kind of take information and represent it. In 3 hours, she makes 21. So in this case, the first number here represents how many hours she worked, 1, 2, 3, and the second number represents how much money she made, $7, $14, and so on. Any question on that? Okay. So actually, this is what I'm going to do next. The number of hours she worked, which are the first numbers, and the amount of money she made, you could write it as ordered pairs, which I actually did below. Okay. So when we write a bunch of ordered pairs, a lot of times they put them in these brackets. And what that means is inside these brackets, that's a set of 4 ordered pairs. Okay? And it's 1 hour, $7, 2 hour, 14, 3 hours, she makes 21, 4 hours, she makes 28. Okay, just as a reminder, what's the first coordinate in an ordered pair? That's which letter?
X,
That's your x, and the second coordinate?
Y.
That's your y. Okay, when you take a bunch of ordered pairs and you group them together, just like we did right here, into a set of them. In this case, there's a set of 4. There's a name for that. That's called a relation. Okay, so a set of ordered pairs is called a relation. It's the first blank to fill in. Why? Because it usually shows some kind of relationship. In this case, between hours and money. Okay? All kinds of relations we could do. The set of your first coordinates, in this case, 1, 2, 3, and 4. Those are called something. Those are called your domain. Okay, that is called the domain of the relation. 1, 2, 3, and 4. Okay, and then I wrote it down right below it. So for our set, the domain is 1, 2, 3, 4. It's all the first numbers I circled in red. Okay, anybody know what the second coordinates are called? Yeah, very good. That's your range. What's my range in the relation up above? Yep, 7. What else? 14? 21? 28. Okay, so the set of all second coordinates in a relation, that's called your range. Marcus?
Need a 10.2, please.
Okay, that's your range. Any question on that? Okay, so a relation has two parts. It has a domain. Those are all the first numbers, all the x's. And it has a range. Those are all the second numbers, or the y's. So for our example, I circled them in green, but I also wrote them here for you. The range is 7, 14, 21, 28.
Wait, so what if you have like names for
You need
domains?
to see the whole thing.
Yep, you can have names too. Okay? So when you write an ordered pair, it doesn't necessarily have to be numbers. Okay, we could do it with an ordered pair, like, for example, Jack, comma, Monday. Maybe that means Jack works on Monday. Okay, Carl, comma, Tuesday. Means Carl works on Tuesday. Whatever your first thing is, whether it's a number or a name, that's your domain. Whatever the second thing is in your coordinate, that's your range. Okay? Everyone understand it could be more than numbers. Okay, so let's look at this. So this could represent, it's a relation, because we have three ordered pairs. It's a set of ordered pairs. And in this case, it represents names and ages. Okay? So let's start with the domain. What's the domain of this set, which we're calling N? You can call this set anything you want. You can call it set A, set B. I just called it set N for names. Yep, James. Chris. And who else? Scott. Okay. Yep, those are your domain. James, Chris, and Scott.
Why is it Chris?
Just how it was spelled. Okay, and what about the range?
19, 19, 23.
So we have a 19. What else do we have?
23.
And a 23.
Oh, you didn't put it once.
Yep, when you have a value that is repeated, you only need to write it once. Okay, so notice in the range here, 19, 19, 23, you only need to write 19 one time.
But how would you mean like what other guys?
So when you're identifying domain and range, domain is the first part of the coordinate. Domain, domain, domain. If you want to know the range, it's the second part. If you have one that's repeated, you don't need to write it twice, just once. Okay, so that's how you identify your domain and range. Okay, let's graph this relation. Okay, and then identify the domain and range. Okay, Dominic, how would I graph the point 3, 0?
3 over to the right.
Yep. Anything else?
No.
Nope.
It's on the x-axis.
Perfect. It's on the x-axis. 3, 0. Okay. Negative 1, 2. Left 1, up 2. Okay. So the graph, we're just graphing this relation. How about 4, 1? How do we graph the point 4, 1? 1? Okay, Elijah, how do we graph the point negative 2, negative 1? Negative 2 is left. Left 2. Down 1. And my last point, I'm going to go right 1 and down 2. Okay, and after we graph it, they want us to identify the domain and range. Okay, who can tell me my numbers in the domain now?
3.
So let's see. Yep, let's try to put them in order. So we got a 3,
-1.
a -1, -2.
1.
Yep, we have a 1.
And 4. We end up on
It's okay if they're not in order, but you can try to put them in order. So -2, -1, 1, 3, and 4. Those are all the first values in each coordinate. Okay, what's the range in that relation?
Yay!
What's the range?
Light up, Mr. Roy.
Isaiah, go ahead, what's the range?
The range is 0 to,
Yep, we have a 0, we have a 2,
you got a 1,
let's see, 0, 2, yep, we got a 1,
a -1,
-1,
and then a -2.
and a -2. Good. Okay, so your range, those are all the y values. Okay, those are all your second coordinates. Any question on how you identify the domain or the range in a relation? Yes?
The domain is the x
Yes.
axis and the y.
Domain is your x's, range is your y's. Good. Okay, this one, we don't have to graph. Let's just identify domain and range.
Do you have to put them in order?
2, 0.
You don't have to put them in order, but
That would be best.
that's generally the best way to do it.
2,
So you got 2,
0,
-1, 2.
3.
0, -1, and 3.
Oh, I did the way it was.
Yep, so it's all the first
Remember, when
coordinates.
you're doing domain and range, think of D, right? D comes before R, all right? So that's your first in the alphabet, right? So D is your first coordinate, right? R is your second coordinate.
Okay, so somebody else, go ahead. What's our range? Marcus?
We have -1.
Yeah, I don't.
Oh, no, -2. That's what I meant.
Yep, -2,
0,
0,
1,
1,
6.
6. Okay, so there's our range. Okay, and he did it in order, which is good. If it's not in order, I'm not going to take points off. But generally, try to put it in order if you can. All right. So the last idea in section 10.2 is a function. Okay. So the idea of a function. Okay, describe it right here. If none of the first coordinates are the same, that's called a function. Okay, so let's look. We had a 2, a 0, a -1, and a 3. Any repeats?
No, function.
Was any repeats there?
No.
No? So if there's no repeats, that's when it's called a function. So in a function, the second number can repeat. That's okay, but not the first number. Let me show you an example of something that's a function. 2, 3, 4, 1, -8, 0, and 5, 3. Okay? If you look at your first number, 2, 4, -8, 5. Any repeats on the first number? No. Some of the second coordinates, those can repeat. That's okay. But to be a function, the first coordinates can't repeat. Okay? So this would be considered a function. Let me show you something that's not a function.
So if it doesn't repeat, it's a function.
Yep, if your first coordinate never repeats.
What if it does?
Okay, if it does, let's say we had something like this. 3, 5, 4, 10, 3, 7, and 5, 9. That's not a function. The reason? 3, 3. 3 repeats.
That'd be cool.
You can't have a repeat in the first coordinate. If you do, it's not a function.
So guys, on your guided notes there, right, on that next page, the back side, it says, when the first coordinates of the domain do not repeat, what's that called?
Not a function.
When they do not repeat.
Function.
Function, right? So that first bullet on that page should say function, and it says when the first coordinate domain do repeat, then it is what? Not a function. That's why there's 3 little blanks there, so not a function.
Wait, so if the range repeats, it doesn't matter?
Exactly, the range can repeat and you're okay. If the range repeats, that's no problem.
Yeah, the second coordinates repeat, that's fine.
It's the domain that can't repeat. If it does, it's not a function. So, both of these are relations. Okay? The top one is a relation, the bottom one is a relation. The difference is, the top one is a relation that is a function, the bottom one is a relation that isn't. Okay? So relations can be one of 2 types. Functions, not functions. All right, so this is similar to what we did before.
Guys, you have that one in your notes. So I bet you guys could real quick right now, I bet you could do the domain and range right now, right on your notes. On the stage, writing it down.
Pretty sure.
Do the domain and range right on your notes right now. Right on those lines, domain and range.
I'm done.
I did both. I know.
Okay, what are you looking for domain? Is that your first coordinate or your second?
First.
First. Okay, Ryan, what's my domain here? So yep, you said 1, that's in it. What else? 2, yep. 3. Anything else? Yep, -2. Anything else? And -1, good.
Guys, when Mr. Hager was doing that, what did you guys notice when he was writing them down? Anybody notice anything?
He does
Put them in order.
You put the commas, good, right? Isaiah said you put them in order, right? You put them in order from lowest to highest.
Oh, wait.
Mr. Hager, do they have to do that?
It wouldn't be marked wrong if they didn't, but it
Okay.
is generally better to put them in order.
Okay.
Yeah. Again, you won't lose points if you don't. But if you put them in order, it makes it easier to find if you have a repeat. Okay? Let's say you had like 10 or 15 coordinates. If you don't put them in order, it might be hard to find repeats. Okay? So let's look at, what's your range here?
Just keep that 5.
What about 5?
Spencer, what's my range?
Your range,
Start with the lowest value.
for example, 2A.
Yep.
Okay, -3, 3, 5, -3, -1.
Okay, so -3 is the lowest. Okay, we got it. And there's a repeat. So do we need to list it twice? No. If it repeats, do not list it twice.
Oops.
We get points off that for that, right?
But then how would you know
Well, we
it's a
get marked off for
function?
that if we list
That.
it.
How would you know it's a function? Well, that you got to go back and look at the original problem.
But if you just write it all down, then it makes it so much easier to see if it's a function or not.
Sure. If you want to write it and then to help yourself, you can write it.
Well, like,
So they put -3, not a function.
So,
You're okay with that?
Yeah. I mean, the book, if you look in your book, it's not going to do that. Okay, they don't write values that repeat. This is just a list of numbers.
But the biggest thing, as long as you guys know that, the biggest thing to take away from this is, if you know when they repeat, it's not a function, then you're in good shape.
So we got -3. I think someone said -1. Go ahead, Kayla. 3 and 5. Good. So now, can we answer the question?
I had a different question.
Yeah.
So if we write -3, -3, -1, will we get counted off for it?
No, that's okay.
Oh, 'cause that's what I do.
Okay, if you write it repeated, it's okay. Again, you shouldn't, but I guess technically it's okay. Now you're answering the question, is that a function?
Yeah.
Did any values in the domain repeat?
Nope.
Nope. So yes, this is a function.
Remember, like guys, like Spencer said earlier, if it repeats in the range, that's okay. All right, it's okay if you repeat.
Say no, say no, throw it out the window.
Okay, how about this one?
What?
What's your domain here?
Domain is section.
Ben, what's my domain?
6.
Anything else? 4? Okay, those are the two numbers that we see in the X box. Okay, how about my range? Yeah, Marcus, just give me one of the numbers.
3.
3? Yep. Somebody else give me another number in the range. Kayla?
2.
2? And there's one more. 1. So now the question is this relation, which we call relation G, is that a function?
No.
No. Not a function. Spencer, why not?
It's not a function because it repeats the number 4.
The number 4 is repeated. Perfect. Yep. Okay, same idea. Let's look at it graphically. So you're going to start to learn that if you graph points and they're a function, they look a certain way. And if they're not a function, they look a certain way. Okay, let's practice just identifying those coordinates. Well, let's see what happens.
It's not a function.
What's this coordinate? The one in quadrant 1.
3, 2.
3, 2. Good. What's the higher point in quadrant 2?
2, 3.
Negative 2.
Yeah.
And then up 3. How about the one below it?
-2, +1.
Negative 2, positive 1. Good. And the one down in the bottom left. Good. Negative 1, negative 3. Okay, so we've listed the ordered pairs. Is this relation a function? No. Why not? Yep. Negative 2 repeats. What do you notice about those 2 points? How do they look on the paper? They lined up which way? Up and down, exactly. If you look at a picture and you have 2 points that are in line up and down, that's not a function. So if you've got 2 points in a vertical line, that means the x value will repeat, not a function. Okay, and let's finish up with this one.
Guys, why don't you go through now, guys, take like a minute, and fill in the coordinates of those points. All right, this one right here. Sam, for this one, this coordinate right here, what you get?
3, 2.
This one right here. It's in quadrant 1. Careful now. Remember, how do coordinates work? Which coordinate comes first? The x or the y? X comes first, then the y, right? Which one's the x? This one or this one? Cross, right? This is my x. This is my y. All right, so what do we get for this one? It's on your paper though, too. The bottom one. We're on, yeah, no. We're on example, what is that? 3B. Yeah, we're on example 3B.
Okay. 2, 3 then.
2, 3, good. So this is going to be 2, 3. Good, thank you, Sam. All right, how about Emma, right below it, this one right here. On example 3B. 1, negative 1, good. How about over here? Justin, how about this one right here?
That is -1, 2.
Good. 1, 2. And then this one right here. Kayla, do this one for me.
-4, -1.
Good. Now, Mr. Nermi, is this a function, yes or no? What, to determine if it's a function, Joe, what should I be looking at? Which one should I be looking at to determine if it's a function?
The one on the right.
Huh?
The one on the right.
No, not the one on the right. What should I be looking at to determine if it's a function or not? Which coordinate? Or which coordinates?
Oh, the wrong one.
Who can help? Austin, how about Joe? What should he be looking at? Which is? Which is? The first what? The first one, right? Again, you're not wrong, Austin, right? These are all my x's, right? Those are all my domains. Whenever I'm trying to determine if it's a function or not, I look at the first coordinate, which, like Austin said, is the domain or the x coordinate. So one of them is -1, one of them is 2, one of them is 1, then I have a -4. Now, what's the rule that makes it a function? Somebody tell me by raising their hands. Ben, since you're so actively ready to participate, I'm going to call on you.
Snap.
Oh, no, it wasn't meant to be taken that way. I just want to get his attention because I want to make sure he knows what he's doing. Ben, so these coordinates, right, my negative, I'm going to do -4, -1, 1, and 2. Is that a function?
Yes.
Why is it a function?
Because you don't repeat.
Nothing repeats, right? That's the biggest thing. If they don't repeat, I'll just put a check mark, or I'll put the function. If they don't repeat, then it's a function, right? Everybody with me on that? Okay, good.
What do you notice if you look at all the points? Are any of them lined up vertically?
No.
No. So just visually, you can tell that too. None of them are lined up vertically. It's not a function. All right. So I'm going to put up your homework for tonight. Okay, the first part is on graphing coordinates. The second part is on functions. So it's page 376, 2 to 26, just the evens.
Make sure you get that written in your agenda, okay?
31 and 32. And then on page 379, it's 1 to 17 odd, and 19.